In this video, we're going to look at finding the first derivative by first principles. So the first example we're going to look at is use first principles to find the first derivative of the following function. F of x equals 4x. So f of x equals 4x is our function, and we're going to find the first derivative of that using first principles. So using first principles, the first derivative f dash x we find by finding the limit as h approaches 0, f of x plus h minus f of x, all divided by h. So we're going to apply that to the function f of x equals 4x. So we're looking at the limit as h is approaching 0 of 4 on x plus h minus 4x, all divided by h. And I'll expand that limit as h approaches 0 for x plus 4h minus 4x, all divided by h. And we notice here this positive 4x cancels the negative 4x. So we're looking at the limit. That should just go back a moment, not correct my error there. It's 4x plus 4h minus 4x over h. And the cancellation of the 4x's leaves us with the limit as h approaches 0 of 4h over h is 4h over h. Now the h is cancelled down and we're left with 4. So the first derivative f dash x equals 4. Okay, so we'll look at another example, and the next example we're looking at is use first principles to find the first derivative of the following function. F of x equals x squared plus 2. So f of x equals x squared plus 2. Plus 2. Now we use the same principle, so we're looking at the limit as h approaches 0, and we have x plus h squared, x plus h all squared plus 2 minus f of x, which is x squared plus 2, and that's all over h. So I'll expand the binomial, the limit as h approaches 0, and on the top we've got x squared plus 2 times xh plus h squared plus 2 minus x squared minus 2 all over h. And I can see certain cancellations again, so this x squared and negative x squared, the positive 2 and negative 2. And then I'll continue it on to say the limit as h approaches 0, 2xh plus h squared all over h, and I can divide out by h, so that will give me the limit as h approaches 0 of 2x plus h. Now we remember h is approaching 0, so the first derivative f dash x is 2x. So that's the first derivative of x squared plus 2, 2x. The last example we're going to look at is use first principles to find the first derivative of the following function. Now we've got x squared plus x minus 3, and we're going to use the same first principle formula to find the first derivative. So let's start off by writing the function. The function f of x is x squared plus x plus minus 3. So we'll just use the same formula, and we're going to do the limit as h approaches 0 of f of x plus h. So we're going to have x plus h all squared plus x plus h minus 3 minus f of x, which is x squared plus x minus 3. And all of that is divided by h. So divided by h. Okay, I'm going to expand the binomial. So we've got the limit as h approaches 0 of x squared plus 2xh plus h squared plus x plus h plus x plus h minus 3 minus x squared minus x plus 3. And all of that is divided by h. And we can look at, again, here we see some cancellation. So we have the x squared cancelling x squared. We've 2xh plus h squared. We've positive x and negative x. And we have a positive h there. We have a negative 3 and a positive 3. So I'll just bring all this together, and we've got the limit as h approaches 0 of 2xh plus h squared plus h all divided by h. We're nearly there now. We can divide out by the h, so we'll end up with the limit as h approaches 0 of 2x plus h plus 1. And as h approaches 0, that will give us the first derivative f dash x equals 2x plus 1. And that's the first derivative found using first principles. So that's all for this video. Thank you for watching.